Red.
Got it.
Got it.
Yep, recording live.
Are live, at least on Monday morning, the 11th of April, everybody. Hello, I'm Baron Ron here, and here we go again, Stargazers. The official, over a year now, SBAU Astro Hour underway, being viewed on YouTube by hopefully a lot of people. Tell your friends about this vlog podcast every Monday morning. Number 59 episode for this week, and it's on behalf of South Coast Longtime Astronomy and Telescope Club, the Santa Barbara Astronomical Unit. We feature the Brain Trust, or who we can get on board, and they're pretty much here except for President Jerry. And it's Mondays, 11 o'clock on. Tell your friends, as we say. Let's meet the gang. Tom Totten is our webmaster. Thank you very much for putting the 5 logos of the club behind you there. We got our incredible outreach coordinator, Mr. Chuck McPartland.
Good morning.
Married to our wonderful merchandise manager, who approved of my running the meeting on Saturday at the Palmer Observatory up at the museum, and Bruce Murdoch.
Oh, where's my hand? There we are.
And you're married to Bonnie. Tom's married to Suzanne. Bonnie is retired, isn't she, from the medical world?
Yeah, she's been retired almost as long as I have. I've been retired, what, 24 years.
Well, I've come to learn that depending on how much she enjoyed her job depends on how much depressed she is about being retired, because I went through depression you wouldn't believe. But this program right here takes care of us. Let me give you some of the headlines we're going to try to talk about. Is Krissie Cook listening? Are you suppose she's on board this morning?
Jim Williams is listening so far. At least his name is on YouTube. He's logged in on YouTube to make a chat.
To call attention to some of our great members, pay homage to Treasurer Colin Taylor, Art Harris, our incredible caretaker of equipment, and Martin and Janet Meza. I met at the Star Party Saturday night. We're going to get a report on that from Chuck. Tess Flanagan and the little guy, Barman, is that his name?
Farshad.
Bar what?
Farshad Barman.
Farshad, okay. And Joe Doyle, who got us our speaker for next month, May. That incidentally will be a Caltech professor, Ben Darvish, who will talk about evolving galaxies. Mr. Webmaster, do we want to call up the president's silly science cartoons? They're not really overly funny, but some of them are kind of cute. And one of them's a video. You want to do that, or you want to try to get into our limited number of talking points? I can read you the talking points. Mercury's back in the evening sky. Guy to talk about that would be Tom Whittemore, but he's not with us today. He's got a dental appointment, I guess. Closest approach of Jupiter and Neptune, a good photo op. And Chuck and Bruce will probably tell us more about that. I'm not going to talk about the mini coat hanger asterism. Curiosity rover is still maneuvering on Mars, even though Perseverance, I thought, sort of took over. Coronal loops, you want to talk about that later? And I had 2 questions I was going to throw at you at some time, stuff I've heard about, I'd like some verification of. But for the silly stuff that we get sent, forwarded, cartoons and whatnot, you call it up and I'll, there we go. My God, those Norwegians, yeah, the Vikings beat NASA to the moon and the Apollo astronaut by several thousand years. Okay, that's great. Good navigators is what Jerry called that. 3 parts to this. Let's see if I can find it here.
Oh, yeah, I like this.
I'll just read it off the screen. Tonight, the guy looks at a meteor shower. Happens once every 1,000 years and it clouded over. Next one, tonight, a lunar eclipse. Only once in a lifetime, and there's clouds. And now it says, tonight, incredibly rare cloud cover. Once in a lifetime. See the cloud formation, and it's bright and crisp and clear and beautiful. Seeing is incredible. That's the way it is usually. There's the mama.
Come on, dang it.
Here we go. Now this one needs some explanation. I didn't get it unless there's something about Schrodinger. About the cat, Mr. Schrodinger, that says I have good news and bad news. All right, Chuck or Bruce, you want to tell me why that?
Well, you put a cat, his whole thing is about a cat in a box. And there's a little bit of poison in there, and there's anything you want, a nuclear decay, and whenever it goes, it can release the poison. But you don't know whether the cat's alive or dead until you open the box. And the very fact that you open the box may cause the event. So
What are
That's,
you talking? Is the guy sitting there?
It's about the uncertainty principle, Ron. The
Right,
fact that the
right.
cat is in a superposition of states until you make an observation.
and his
Right.
name, and the scientist name who got the award for that came up with that was Schrodinger.
Yes.
Yeah, Schrodinger.
Oh, okay. There you go. Then I got it. I just didn't
Was
know
this in
the name.
particular, he was looking, they were talking about looking for an electron in a position around an atom? Is that what it started? Or
No, it was nuclear decay that's sort of random and it's a quantum mediated process. And the idea that sometimes it's the act of observation that collapses the state of the system.
Well, that's
Uh-huh.
like Heisenberg's uncertainty principle.
Yes, yes.
Same
Schrodinger's
thing.
cat is kind of an example of that.
Yeah, I remember him. I heard his name. I had not heard of Schrodinger. What? Okay, what do we got? The mama bear says to the baby bear, I'm a happy mommy. They named the stars after me. Yes, little bear. Okay.
that refers to the Little Dipper, Ursa Minor.
That's in today's talking points, I believe, if we're going to go there. I'm not, that might be that stupid coat hanger thing.
That's one where the finder chart that's provided doesn't give you really any information, and
All right, we don't have Jerry here.
yeah,
the
it's pretty
president.
obscure.
All right, President Jerry is on assignment. Here we go.
This one had me confused for a while.
Yeah, this is a good one.
Let's see, where is it now?
What's on
Keyboard.
your screen, Ron?
Well, I write it down. Keyboard simply asks, where do astronauts hang out? Sitting. It's about the T button, isn't it, or the B, or is this?
No,
No,
that's a
Ron,
space bar.
Yeah.
Well, he's sitting at the space bar, but he's sitting on one of the lower. I do have-
Space bar. He's sitting out. He's at the space bar.
Astronauts hang out at the space bar, Ron.
I understand that, but isn't he sitting on one of the keys?
Oh, it could well be.
Okay, well, I'm
But he's
not-
bellied up to the space bar.
Let me look. It's either a B or an N on mine. That's about
Well,
where.
he's probably not, Ronnie's probably not sitting. He's kind of hanging on the space bar
Oh,
there.
I see. Okay. One of the things that bothered me about 2001 Space Odyssey is those two effeminate looking young astronauts. They didn't give a darn about anything. You know, when the family tuned in from Earth, wishing the guy a happy birthday as he laid there, he just sort of said, lifted a little Hal. Gave me the impression, you know, the computer has more humanity than the people on board, but I'm the only one that thought that. Any more, Tom, or you want to go
Nope,
right?
that was it. Yeah.
Okay, then I'm going to leave it up to the gentlemen that are pictured on the bottom of my screen to determine where we go. Mercury back in the evening sky or close approach of Jupiter and Neptune. We had something about the moon, but there's also coronal loops we'll talk about, maybe an illusion. Chuck, I'll let you pick the first topic and let's get into it.
Well, we might as well go in order because Jerry copies these from Astronomy Magazine and they're kind of in the order of the weekdays. So
All right.
his first talking point was the winter constellations are kind of going away. They're low over there in the west. The finder chart he provided is pretty cluttered and hard to read, but you can see Taurus is pretty much set, very low to the horizon by the time it gets good and dark. And Orion is there with holding up his shield and he's got his club. But this is just a stick figure, so it's kind of hard to make that out.
Stick figure.
And then he talks about over there, okay, over where Tom is now, well, where he was, over in the left edge there, Orion has two hunting dogs. If you follow the belt to the right, you go to the Pleiades, which are shown just sitting behind the hill over there. And if you go the other way, it kind of points to Ceres, which is the brightest star in the sky. Bright because it's close. It's only about 9 light years away. It's not intrinsically bright. And that's the heart of his big dog. He has two hunting dogs with him. And then if you go up near the top, you have Procyon, which is another star that's bright, but only bright because it's close. It's about 12 light years away. And that little star Gomesa, you have Canis Minor, the little dog, who's just a hot dog. And some objects to see in there, Betelgeuse is a star in the shoulder of Orion. It's a red supergiant star. The talking points actually said it was a red giant, but it's not. It's supergiant. It's much different than Aldebaran, which is also red, one of the eyes of the bull. But what they share is a color, and that's because of their surface temperature. But otherwise, they're quite different stars. Aldebaran is like our sun, but just farther along in its evolution. And then Betelgeuse is a much more massive star, which lives fast and dies young. So much younger than our sun, but at a very advanced state of evolution, close to blowing up in a core collapse supernova.
Hmm.
And then it mentions the belt stars, Alnilam, Alnitak, and Mintaka. So there, you know, a lot of cultures see that, those triplet of stars there, the belt of Orion. And then off of Aludra and Wesen in that area in Canis Major, in the tail of the dog, there was a description of how to find what's called the winter alberio. There's a star in the summertime that you can see called alberio, and it's quite fun to look at because it has a nice color contrast with one blue and one yellow. So we often call it the Cub Scout star or the UC star. And there's a similar star near the tail of the big dog there. Okay, and yeah, so it has a nice color contrast, in a similar way. And it's actually, I think it's not as easy to split, as you need a little more magnification than for alberio, but it has really intense colors. So it's a very pretty sight.
You mentioned, Chuck, this is time for my dumb question. Betelgeuse is a giant, red giant. And
It's a supergiant.
Supergiant, okay. Our sun is not going to be a red giant, and yet
Yes, it is. Our sun is going to be a red giant.
Oh,
a red giant is like Aldebaran. A red supergiant is a very massive star.
Okay, well, our sun supposedly is going to swallow up the Earth someday, and that's 93 million miles away. Right now, it's less than 1 million miles across diameter.
It's not going to reach the Earth, probably. It's going to swallow up Mercury and maybe Venus.
Oh.
But the surface will get, of course, closer to us because it's going to swell up quite a bit. And it'll get much hotter here. It's going to be bad news, but we're working on doing that ourselves.
Well, of course, and that's several billion years in the future. Okay, so we're a giant.
So Ron, here we go. Here's a life cycle of a star.
Well, that's of a sun, and that's a very massive sun if it goes to red supergiant. And if it's red supergiant, it doesn't go to planetary nebula. So this is a goofy. Yeah,
a little bit off here.
Yeah.
But yeah, we skip here. So say if we're the average star, we go to a red giant, and then we go to the planetary nebula in a white dwarf stage.
Right.
The red supergiant, it goes to a supernova.
Yeah.
How about red dwarfs? Do red dwarfs expand in their lifetime?
Maybe a little bit, but not much. They don't have much mass. They live for a long, long time, mainly just converting hydrogen to helium.
Okay, but the mass itself, if it gets bigger, if our sun is going to get that large that it swallows up Venus, what happens to the material? It doesn't get any more material. It's just expanding.
That's correct.
Bruce, you're not communicating clearly.
You're breaking up, Bruce.
No, it got a weak connection somehow.
Ron, what happens is
internet.
Is that better?
Nope.
We hear pieces of you. Sorry, Bruce.
Ron, what happens is, okay, the star swells up. It does not gain any mass, but the mass distribution changes. So the majority of the star becomes very, very tenuous. It gets a denser core, okay? And some of that mass may actually go away because it can escape the gravitational field of the star now. So you can, that's what ends up forming a planetary nebula. Some of that stuff that's been burped off that kind of escapes.
Okay, but supergiant Betelgeuse, we can probably estimate with no way of proving that it did swallow probably some planets it may have had at one time, right?
It could be. It could very well be. We have no way of knowing that.
But Proxima, what's it called?
Proxima Centauri?
Yeah, Centauri is not going to get its one little, well, that's the name of the planet, though. That's not the name of the star it's around.
No, Proxima Centauri is the name of the star.
Oh, okay. Then what's the planet called?
Proxima Centauri b.
Okay, there's little chance it's ever going to be swallowed by that little red dwarf. They don't.
That is correct.
Okay, fascinating stuff. Interesting, gentlemen. Can I throw one of my questions at you that I ran across, and you can tell me this is all fake news? Wednesday, March 30th, I saw on a YouTube video, NASA announced the farthest star ever seen by the Hubble telescope. I can't imagine people just making up this. star formed just 1 billion years after the Big Bang. It's called Arundel. Has anybody heard of that?
Yeah, that was just a recent announcement from the Space Telescope Science Institute and NASA.
How in the world can we
And
see
they just gave it a
star?
name, you know.
What?
They just gave it a name. Arundel is from Lord of the Rings.
Okay, but how do we see a single star? I mean, it's hard enough to see some of the galaxies that are.
Okay, they got lucky, and it's gravitationally lensed. Okay,
Ah,
so the gravitational lensing concentrated the light, and they were able to see it and detect spectroscopically that it was an individual star.
so if it's lensed, then it's behind a galaxy, right? And forming
Or a galaxy cluster, a whole cluster of galaxies.
how do they know it's not a galaxy instead of a star?
Because they can look at the spectrum.
And it stays the same.
Well, not that it stays the same, but it has the characteristics of a single star.
And it's sitting
We've
out there.
also got the Einstein ring that it's part of.
Well, that's gravitational lensing.
I understand. That's that thin red line, it's curved red line.
Look, it's the smiles, the smiley face. That's part of the. I don't know why the whole sky isn't gravitationally lensed.
It is pretty much.
Is it? Okay. Well, interesting that's true. All right. Fascinating stuff. Any other points to make? There's a bunch of stuff in this article about winter constellations. What else should we talk about or consider beyond that map?
Oh, the ones that are setting, that pretty much showed, you know, it's that whole winter circle of bright stars is going away.
Oh,
So Chuck, what is the circle he's talking about? It's Aldebaran to where?
Betelgeuse is pretty much the center, and you can come down to Aldebaran, and then you go up to Capella in Auriga, which is a yellow supergiant star. It's about the same surface temperature as our sun, but much larger. And then you go up to Castor and Pollux in Gemini. They're still hanging around, but they're just
They got
off of
cut
that
off.
picture. Yeah. And then you come down to Procyon in Canis Minor, and you come down to Sirius in Canis Major, and then you come down to Rigel, one of the feet of Orion. You know, in the write-up, it said Rigel is a knee of Orion, but it's actually one of his feet. Rigel means ankle or foot. It comes from an Arabic phrase that meant ankle or foot.
really? I got a sprained Rigel. Okay.
Yeah.
Wow, fascinating. Is that scattering of stars, are they close together at all of them, or are they just everywhere in the spur and the arm?
Yeah, they're just randomly distributed. Oh, they're all relatively nearby as far as the galactic position, but their distances vary by quite a bit. You know, Rigel's like 800 light years away. Betelgeuse is 600 light years away. Capella's only like 47 light years away. Aldebaran's 67 light years away. Sirius is only 9. Procyon is only 12 or so.
And if there are intelligent creatures out there on a planet, they have a totally different set of constellations, don't they? Everything different in their sky. You could probably have fun just conjecturing if you're a sci-fi writer. Okay.
Well, many of the planetarium programs, I know Sky Safari used to do this. You can click on a star and say, go there. And it will actually move you several light years away from the sun. And then you can rotate around and look back toward the sun and see what the constellations look like. And they're quite distorted, of course, if you move a great distance.
And yet, as we learned last week, some stars are moving, but they never move enough to.
They all are, basically.
Some
They're
of them,
just
depends on
really
the
far
time
away,
frame.
Ron.
what'd you say, Bruce?
It just depends on the time frame.
What do you mean?
Some move quickly in a you know, some of the stars that they look at over a period of years and they move. They move with respect to the background stars. That's because they're closer to us.
But basically, they're all moving some way or another in the turning of the galaxy in the direction the Milky Way.
That's correct. Some are moving along with us. Some are moving, like Arcturus is actually moving quite a bit differently than any of the other stars near us. And that's because it seems to be a star we've captured from another galaxy or from a collision. And it's got a different motion than the bulk motion of the stars around us.
Really? How would they know that?
Well, they can measure its motion.
And know that it got captured when we collided and two galaxies went through each other and one of them decided to leave a star behind.
Well, it probably was a small galaxy that we gobbled up.
Oh, okay. One of the orbiting, what do they call the triangulums and Magellanic?
Yeah, just local small galaxies, like the large and small clouds of Magellan.
Okay, there used to be a lot of those, and there's less and less all the time. Interesting. Okay, anything else you want to talk about on that, or you want to go to Mercury back in the evening sky?
Well, yeah, let's go to Mercury.
Something about its
Jupiter.
position. What was the word? I don't have it. It's on the
Superior
far side.
conjunction.
Conjunction. Yes. What does that mean?
That means it's in the nearly the same part of the sky.
As what? I don't understand. Nearly.
Well, when two things are close together in the sky, it's called a conjunction. And
Oh,
superior
okay.
conjunction is when Mercury is on the far side of the sun from us. Inferior conjunction is when it's on the same side of the sun as us.
And we look down its platter, its equatorial plane. Is that what you're saying? In other words, it's either on this side or that side, but it's in the same place in the sky. It's just a little dimmer if it's on the
That's
other
correct.
side.
That's correct.
And
Not really the same place in the sky, but relative to the sun, it's close.
okay. That would make sense.
And so it's actually going to be better later in the week because for us, over there in the western horizon, it tends to be, there's a lot of haze and stuff lately. So probably later in the week, it'll be easier to see, but it gets fairly bright and it's interesting to hunt it down. Okay, so by the end of the week, it'll be 5 degrees high, 30 minutes after sunset. So that'll make it a little easier to find. 5 degrees is like half a fist width, so it'll still be pretty low.
Tom, can you go back to that little mini solar system you were just showing? Because there's a missing planet. We're the second from the sun in that photograph.
No, well, this is showing Venus. If you look at what picture of the planet it is.
And
But it's
where's
just an illustrative diagram, Ron. They left off Mars too. They just put out, it's
Oh, I
just
understand.
showing you that superior planets that are farther from the sun than we are have what's called opposition in conjunction. And then inferior planets have inferior and superior conjunction.
Do we ever see the transits? I guess we do. Don't we have
For
Venus
Mercury and Venus, yes.
always, or do they ever go above or below the sun?
No, most of the time they go above or below because they're tilted slightly. And the sun is only 30 arc minutes across.
Huh. Okay, it's 800,000 miles in diameter, isn't it?
Yeah.
Give or take. It's one of the few things I've learned. So the next planet, Mars is not on there?
No, Mars isn't there. They're just showing that the names for the different conjunctions, but they have different names depending on whether it's a planet that's farther from the sun than we are or closer to the sun than we are. It's just an illustrative diagram. It's not meant to be a diagram of the solar system in general.
What does that mean for viewers with a telescope or binocs? Anything? Can you
Well,
see it?
when an inferior planet is near conjunction, it means it's very close to the sun, so it's probably hard to observe.
Oh, yeah.
When a superior planet is near opposition, that's the best time to look at it because it rises at sunset and it's up all night. But when it's in conjunction with the sun, you can't look at it.
Conjunction. Is it only one place or two places in its orbit that it is in conjunction, or could it be many places along the side or either side of the sun?
Well, it depends on the relative positions of the planets.
Okay.
And they're all orbiting at different rates, so it's not like it's one fixed spot in the orbit.
And it orbits what, 1/3 of our year?
What do you mean?
For Mercury?
For
Yeah.
Mercury.
Mercury's 88 days.
That's about 2.5 months. That's less than 1/3. Yeah.
Yeah.
And then
That's why it's named for a guy with wings on his feet.
Mercury. Okay. All right. Want to go to Jupiter and Neptune, the photo op? Bruce is our photo op guy, aren't you? You're a
Let's see.
well-known photographer,
Yeah.
astrophotography guy. Have you ever done Jupiter, Neptune,
Oh, yes, yes.
Saturn, of course, many times?
So this is only
Neptune
good.
is, it's like a star.
Say it again. You cut out.
Neptune just looks like a star.
Yeah,
We
sorry,
really
Bruce,
can't hear
you're
you. We really can't hear you, Bruce. You're breaking up.
too
All
much.
right, well, I don't know what's going on here.
Yeah.
You might want to go back to the microphone built into your unit.
Yeah, so
Okay.
the article about the close approach of Jupiter and Neptune, that's pretty much good at about 6 a.m. On Tuesday morning. Okay, so tomorrow morning.
6
That they're going to
a.m.
be that they're closest. Now they'll still be close all week, but this is referring to their really close conjunction. They're a tenth of a degree apart.
Okay.
And so Jupiter will be shining brighter, of course, than Neptune. You'd need binoculars to see Neptune.
How many arc minutes is a tenth of a degree?
6.
6. Okay, but we're not going to be able to see anything at 6 a.m. It's getting light by then, isn't it?
No, that's about a half hour, 40 minutes before sunrise.
Okay. Look at this.
You know, Jupiter is so bright, you'll see it easily. Neptune, you'll need binoculars.
What's the status of Juno? Still going around?
Still going around. They've extended the mission. They've used less fuel than they expected. So, and the instruments are still in good shape.
And we learned that the roiling clouds on the poles are blue, haven't we? Pretty much. Blue and white on the top.
Well, that just depends on the spectral band probably that you look at them with. Also, you know, there's a mention, of course, the people that are listening don't see these talking points, but it also mentions that if you're looking in binoculars at Jupiter and Neptune, that you'll see the 4 Galilean moons, Io, Europa, Ganymede, and Callisto. And it mentions a specific configuration of the moons, with Io alone east of the planet and Europa, Ganymede, and Callisto sitting to the west. But that's really only good on Tuesday morning. If you look other mornings, Neptune will be a little farther away, and the alignment of the Galilean moons will be different.
Okay, so the farther away means that obviously Jupiter is passing it. It's obviously going a little faster in its orbit than Uranus, than
The Neptune.
Neptune.
Right.
Neptune is farthest out there, isn't it? But a good photo op.
Yeah. I mean, you'll have to kind of overexpose Jupiter to get Neptune in there.
Take pictures.
Where would Uranus be right now?
Uranus is in the evening sky, just barely up at sunset.
Okay, but nowhere near this grouping here,
No.
but you can see it.
You'd need binoculars probably right now since it's so low in the sky. And you'd have to look right after sunset. It's getting near its conjunction with the sun.
And last week on the program, we learned from one of Jerry's cartoons, they want to rename it Doug
Yeah.
instead of Uranus. Are you doing any photographing, Bruce?
No, night sky is favorable.
Maybe if you talk slow, we could get every word. I think you're okay.
Let me put the microphone right in front of lips. Is that any better?
No.
It cuts out every so often, my friend. You want to talk about Schroeder or Schroeder's Valley on the moon?
Schroeder's Valley. It's an interesting feature on the sun. Tom, yeah, you can put that picture up. I don't know that that's the best picture, but
Not the
it is
sun.
high contrast. The reason this is included is because it's
That wouldn't be, here we go.
yeah, this is talking about Wednesday when the moon comes up, because it talks about the moon being up a certain time after sunset. And so you'd have to add about 40 minutes each night. So let's see, where was that? An hour after sunset on Wednesday, but each night after Wednesday that you do it, add about 40 minutes after sunset to go look. And the aspect of the sun will change with each one of those days. And so the valley will gradually get harder and harder to see. But it's a neat little rill that seems to have been caused by, flowing lava. This is like a collapsed lava tube that forms this pretty deep canyon. It's 25 miles wide and 2 miles deep. So
Wow.
it's deeper than the Grand Canyon.
What phase will the moon be in Wednesday?
This is going to be, it's an hour after sunset. So this is waxing gibbous.
Okay, it's
I'm sorry, waning gibbous, waning gibbous.
going down in size, but it's
Yeah.
less than half a moon size. It's not quite a crescent.
Right.
Okay. The guy's name is Scroteri, you suppose? Schroter?
Schroeder, he's an astronomer, scientist.
The name on the screen says Vallis Scroteri. I assume that's Italian for Schroeder's Valley.
No, that's sort of a combination of Latin and the guy's name.
Well, the guy's name looks Scandinavian with the 2 dots over the O.
Yeah, I'm not sure what his nationality was.
You know, that's the first time I've heard the word rill in decades. I wonder why they stopped. I hear Maries. And,
Well, you know, those are different geological features. The rills are these little canyons and cracks in the surface of the sun.
what is Cobra Head?
I mean, of the moon. Pardon me?
Cobra Head, like Diamond Head in Oahu.
It's a feature that looks like a heart. It's kind of heart shaped, so that it looks like a cobra with its neck expanded.
Wow. Okay, so that line is a rill that
Yes.
the upper arrow is pointing at.
Yes.
And it's Herodotus at the back. I can get that name, Herodotus and
Yeah,
Aristarchus.
and Aristarchus.
Wow. Well, I got lots of places to choose from to set down and build a colony if they ever do it.
Yeah. Well, you want to go somewhere where there's water, so that's why everybody wants to go to the
Poles.
southern area there, where you have the Aitken Basin. Yeah, where Tom's circling there.
If at one time there was water all over the moon, it would have been steamed out by the sun anywhere except where the shadows are always there. The poles.
Pretty much, yeah.
Herodotus, that's a crater, right?
Actually, it's interesting. The solar wind actually can make water on the moon.
You're kidding.
Yeah, you know, you've got these protons that are basically hydrogen nuclei that are being streamed out of the sun that hit the minerals on the moon, and some of the minerals on the moon have oxygen as part of their structure.
Okay.
And so you can end up forming water in the minerals. We're getting feedback from Bruce's microphone here.
Okay. Well, I'm not hearing myself, but this is fascinating stuff. Incidentally, since I got you on the screen, Mr. Outreach Coordinator, give me a quick report on Saturday night. How I had to leave and go to the ER. That's another long story. I'm okay. I'm going to live. How was it, our attendance at the Star Party?
We had 494 people, so another crowded night. We only had
Wow.
9 telescopes, so people had to kind of stand in line. But it was a decent night. It was good conditions as far as the temperature was very pleasant and there wasn't any wind. Mostly, you know, a lot of people were focused on the moon because it was up and fairly bright and drowning out some of the deep sky stuff. But Sean was running the big telescope. Sean Kelly from City College was running the big telescope, and they got some views of the Orion Nebula and some star clusters. So it was a nice night.
See anybody that other than Sean, Mr. Headland, did he show up, or somebody from City College, or the mayor, or John Palminteri? None of the
No
crazy-
celebrities as far as I know, but I was busy. You know, I had the bracket so people could take cell phone pictures of the moon.
Yeah.
So I was pretty much spending the night screwing people's telephones into the bracket and hooking them up to the telescope.
Take their own picture.
Yeah.
That's great. I had no idea you could do that.
Yeah,
Also,
people have fun with that.
Third Friday of the month, you do it at Westmont Observatory.
Second Saturdays at the Museum of Natural History, third Fridays at Westmont. So this Friday will be at Westmont.
Well, here's the picture, the question that inquiring minds are wanting to know. Do you still have the 5-pound meteorite and do your little soliloquy about older than dirt?
I still have the meteorite. With COVID, I have not been handing it around.
So my question is, can you remember the whole thing?
Oh, absolutely. I've said that so much that it's burned in.
Well, I'm almost tempted to ask you to see if you could rattle it off right now, but you don't have it in your hand, so you're in the house.
Plus, it'd be kind of silly to say, don't drop this on your toe or you'll look like a duck if I don't hold it.
And then something about nickel. It's made of nickel. It's
Iron and nickel, yeah. 92% iron, 7% nickel.
God, you'd think it would be heavier metals than that, like lead or gold, but I guess all metals are heavy. Aluminum's not too heavy, you know, that we don't get meteorites made of aluminum, do we?
There are aluminum inclusions in a lot of the rocky meteorites because they're, you know, they're mineral based, and a lot of minerals have aluminum incorporated in them. Calcium, aluminum, you know, and especially lunar meteorites have a lot of aluminum.
But you hear the biologists say amino acids, the building blocks of life. There's some in the meteor. What the heck are amino acids? Are they a rock-like material, a
No,
mineral?
they're just basically, you know, small particles of, I guess you could say small food particles.
Food particles.
Well, that's what you break it down to when you digest food.
Oh man, that's crazy.
I
Bruce,
think
are you-
amino acids tend to be parts of proteins.
Yeah,
proteins.
they're the building blocks of proteins.
Well, I know that, and I love protein, especially if it's a good expensive steak. Bruce, are you okay now? Can we hear you? Oh, you're gone.
You're muted, Bruce. You're muted.
Click the mute button on the lower right of your screen and join us again, my friend. Maybe you'll be all right. Uh-oh.
I can probably
So much for the headset.
Any better?
try it again. Say something.
This is a new set, new phone set. So
No, yeah, it's breaking up. Yeah, not working.
I'm just glad you're not an air traffic controller directing an airplane of 300 people. That would be awesome. You want to talk about Curiosity rover maneuvers?
Sure.
Oh, before we go there, Chuck, what's the Astronomy Day thing? We want to get that in because it's going to happen,
yeah.
right? In May?
Coming up for May, on May 7th is International Astronomy Day, Saturday, May 7th.
Okay.
And every year in the past, we've set up either at the museum or at Camino Real Marketplace. With the museum's conditional use permit, we pretty much have moved to Camino Real Marketplace these days. And so we'll be out there in the plaza that's next to the theater and the restaurants in Camino Real Marketplace all day long on Saturday, May 7th, for International Astronomy Day. We'll have solar telescopes set up for viewing during the daytime. And then in the evening, we'll have a star party to look at the night sky and the moon. And we're not gonna have quite as many activities as we had in the past because we're sort of just ramping back up again. We're gonna have a couple of tables with some activities. And we usually have astronomy goodies like planispheres and astronomy books. And sort of tchotchkes that we give away. We'll have an instant win drawing where if you go to a telescope and view through it, you get a little, basically a ticket with a number on it, with a random number on it. And then you go to the table that's the information table where we have propaganda and stuff. And they'll check your number against a list. And if you're an instant winner, you get to pick a goodie from among the list of things we have. I don't know if Tim's going to do the mirror grinding. That's a lot of hauling for him, so he might just be doing solar observing this year. And also, you know, Tom, it was nice that you brought out the UC2. At the Saturday Star Party, Tom set up the UC2, which is our special mounting for people who are handicapped, especially in wheelchairs, to be able to look through a telescope, because otherwise it's hard for them to get up to a tripod. And it was nice that we had that because we had some people take advantage of it on Saturday night. And it would be nice to get that out on Astronomy Day, but we don't have a way to transport it very easily. Yeah, here's a picture of it set up. You can see how the telescope is out on a cantilever arm so that people can easily get a wheelchair in under to get the view. Now, usually we have that set up at Astronomy Day, but I don't know how we're going to get it to the marketplace on Saturday because
If we
I don't
can
think
get
we have
Ruben,
anybody
Ruben
who-
would volunteer, maybe.
Yeah. So if we have somebody in the club that has a vehicle that can haul that out there, you know, it comes in a couple of pieces, but we have to get it out there. And Krissie won't be able to get the museum's truck like Javier could in the past. So it'd be nice if we can get that out there.
That machine we're looking at enables people in wheelchairs to what?
Yes. to get to the eyepiece of the telescope easily.
Oh, it lifts them up.
No, it cantilevers the telescope out on an arm so that they can wheel the wheelchair in under it and get in to see it.
Oh, how many of those type people do we get? Handicapped folks in wheelchairs.
Oh, we get a few.
I had 3 that I had to adjust for on the outreach.
So the machine is there at the museum. That's where it stays.
Well, no, that's not where it stays. It is transportable, but we need to get somebody with a vehicle capable of transporting it.
Oh,
It's heavy, isn't it?
It's
Yeah.
fairly heavy.
Yeah, it's a big,
Okay.
heavy hydraulic unit with big arm. Yeah.
well, that background of that picture is where we held our meeting on Saturday. And thank you, Bruce, for being there. I know we can't necessarily hear you.
In there.
Yeah, we're getting feedback from your microphone, Bruce. When we speak loudly, it feeds back through.
Well, I tried, but
Trying to make his computer microphone.
Yeah, sometimes Zoom, if you have a fancier computer, Zoom can block some of that background noise, but using a cheap tablet, it doesn't work as well.
I was wondering
Got it
what
better?
the world this Zoom handles feedback since we're all hearing it loud and clear. But I guess it's instantaneous. It just doesn't feedback. That's our Palmer Observatory, folks. I didn't
Yeah,
realize
there's a
it had.
20-inch telescope in there that was donated.
Was it? Like somebody named Palmer?
No. That's the old name of the observatory, but from people who donated to make the observatory. But the telescope was donated by Wayne Rosing, who's the founder of Las Cumbres Observatory.
Uh-huh. And so we've got up in size over the years, and ours is not as big a telescope lens-wise as the Westmont, is it?
Well, it's a reflector, so it's mirror, not lens, and it's 20-inch at the museum and 24-inch at Westmont.
Are lenses on the way out?
Well, Ron, lens refers to a lens, which is used on a refractor telescope, and it's hard to make those large because the glass slumps under gravity and you can't keep the figure. But big telescopes are made with mirrors.
And the lenses were always in the front, and then there's a little lens in the eyepiece.
That's a refractor.
Okay, refractor only, okay. Well, are they open for this? Are people coming to the museum and staying outdoors, but they can go into our observatory, or is it only for us, for our meetings? Does anybody know?
No, it's some days it's available at the museum on the weekends for people to come in and do solar observing. There are a couple of grad students from UCSB that come out and kind of host the public at the observatory, but I don't know that it's on a fixed schedule.
Uh-huh. Krissie would, wouldn't she?
Well, Krissie's busy running the planetarium and she's only part-time. So no, Krissie can't go out and run it.
But people aren't flooding in and sitting in the planetarium, are they? That's inside. They're not allowed.
No, there are no. Oh, the planetarium. Yeah, the planetarium is open on the weekends.
Is it?
And there are, 5 or 6 shows each day. I was there Sunday doing 3 shows.
Seems to me you could catch COVID in there just like you could inside where all the displays are.
Yeah, it's there's a sign at the entrance to the museum that masks are recommended, especially if you're indoors. And for volunteers with the museum who are dealing with the public, you're required to wear a mask even outdoors. And there are a couple of I don't know what to call them, air fresheners. There's a couple of fan-based units that are in the planetarium that are air purifiers.
Would it be safe to realize or to think that if they ever open up the museum to everybody, we can go back into Farron Hall on our first Friday meetings, probably?
Well, they've opened the museum up to everybody now, but indoor meetings, I think it's a little premature for that.
I got to get.
That's a fairly small room to have a bunch of people in, and I don't know that the ventilation is that great.
Well, I'll email you after the show to get the lady's name that I forgot it already that I got to check with and get vetted because I've been, incidentally, Bruce or whoever, Chuck, did you get your second booster shot?
Not yet. Bruce has.
Bruce did, and I wonder
he
if
said it pretty much, he slept all day after getting it.
I understand that. I'm willing to do that. I'd love to have a good sleep, but I don't know where to go. Is it out at Cottage, Goleta?
Well, you can, from what I've heard, you can contact your physician or pharmacies that'll have it.
Oh, there you go. Okay. We got about a quarter hour left. You want to talk about Curiosity rover maneuvers? We're not going to do the coat hanger asterism because,
Sure.
sorry. Or coronal loops of the sun, maybe an illusion.
Yeah, the Curiosity rover, you can see this picture here that Tom put up.
Oh, there we
They've
go.
encountered some very sharp rocks. The rocks get eroded basically by the wind, and they end up with these sharp edges. And they tried to make the wheels tough but light on the rovers. And so they're fairly thin. And when they roll over these rocks, you know, with a 500 or 600 pound rover, it breaks holes in the wheels. And so they're trying to preserve the wheels. So they're going to actually back off and go around another way to get to where they want to go here on Mount Sharp, so that they don't run over these rocks and damage the wheels any more than they need to.
Is Curiosity the one that's paired with Spirit, or is that Opportunity?
That was Spirit and Opportunity. They're both dead.
I know. Why is Curiosity still alive?
Well, the earlier ones were powered by solar panels. And the
Right.
solar panels eventually get covered with dust and lose efficiency. And if you have a big dust storm, they die. And that's what happened. One of them, Spirit, got stuck at a bad angle in some loose sand and couldn't replenish its batteries. And then Opportunity basically got caught in a big sandstorm long enough that its power went down so that it couldn't heat its instruments, and the cold of the Martian night basically killed it. Okay. But Curiosity and Perseverance are powered by a nuclear radiothermoisotope generator, so they don't rely on solar panels.
Huh. So there's
So they're both still going.
A little bit of radiated element.
Yeah, there's plutonium in these RTGs, and it generates heat, and they use the heat difference to generate electricity. That's a new thing that they're actually putting on solar panels now, or they've developed for solar panels. I don't know that it's actually going out commercially yet, but basically your solar panels can now generate electricity at night based on the difference in temperature between the solar panel and the night sky.
I thought you were about to say they had plutonium in the solar panel.
No, we're not widely deploying plutonium to people's roofs yet.
Well, at one time they wouldn't launch anything with radiation, plutonium, because it might crash.
Well, there was a lot of controversy about that, but they never stopped launching.
Bruce, are you with us?
Oh, so can you hear me now?
Pretty much.
Still breaking.
Breaks up a little.
Well,
Okay.
I can reboot my computer.
Well, why have they abandoned Perseverance and its little helicopter? They must be flying all over Mars.
They haven't abandoned it. There was just some news from Curiosity.
I know, but we don't get anything week in, week out here about Perseverance and Ingenuity.
Well, if you go to their webpage, actually, yes, you can see updates from what they're doing.
They're
flying a helicopter quite a bit. They've really extended its mission. Ingenuity.
Right. So they've been using it, and yet I don't hear anything about it.
Well, they're probably transiting to a new area of interest.
Okay.
It's they move slowly, relatively speaking.
The little helicopter has a camera on board, right?
Yes.
Transmits back to Perseverance, which then sends it to the Earth, I guess. Right?
Which sends it to an orbiting satellite, which then sends it to the Earth. Although I think Perseverance can also talk direct.
Wow, fascinating. Have you ever heard of the word pediment before? Do you know what a pediment is?
It's like a base structure on a column or on a statue, and in this case, they're referring to the geological structures that they're exploring. Well, so this pediment is where you think you have there's sediment as water poured into this crater that they're exploring, and so they want to go look at these sediments. especially because that's where they could find concentrated evidence of previous life forms, if there were any.
And this one, Curiosity Roving On, is named after something named Green Bow, I think. I can't tell you how you pronounce the second part of that word. Greenbeau.
Green hue.
Green View, okay.
Hue.
Hue, it's an H.
Yeah.
Oh, okay, pediment, fascinating. There it is, Green Hue. Huh, things we learn on this program, ladies and gentlemen. I have Mars all mapped. Suppose we'll have as much debris going around Mars someday as there is around Earth.
We tend to leave litter wherever we go.
We sure do, don't we? And I saw a video that said Russia has screwed it up permanently in space by blowing up some of their satellites, doing some practice war maneuvers up there.
Well, that was China that did it the last time, but Russia's done it too.
And the Ukrainian flag behind you, Chuck, is called up off the internet. You don't have the actual flag there in your room, do you?
It's just a PNG, just a portable network graphic that I said use this as my background.
A great statement. I thank you. Coronal loops may be an illusion off the sun. That's all I managed to transcribe, and I was hoping to have the subject matter in front of me on the screen, but I couldn't do it. Actually,
so what that article refers to, coronal loops, are these filaments that you see sticking up above the sun like that. And, just from their appearance, people thought they were indeed shaped like these loops. And they're magnetic field lines that are holding up charged plasma. And so that's why you see that, and they often have this fan shape. But it's difficult electromagnetically to hold it into a tiny tube like that. So they think actually now they've done some modeling and they think it's not a tube, it's actually a whole sheet. And what you're seeing, okay, so on the left, we're seeing in effect the shadow, okay? And if they were loops, you'd see these tiny little loops. But if they were more like sheets of current, which is easier to, more likely to be the configuration it is, when you look at the shadow, we're seeing only the denser regions of the shadow in the background, and they have a similar appearance to the simple loops. And so now they're thinking that it's more likely sheets of this material. And the reason you see the loops is because as you look transversely through the sheet, there are some areas where there are folds and wrinkles where you're looking through more material, so it looks denser, and thus you see what look like loops.
so which of these pictures is more accurate? The one on the right?
We think the one on the right now, yes, but the one on the left was the simple model that we used to use.
Now, what was that story we had a week or two ago about the terrible storms? That's not what we're talking about on the
Well, it's similar. I mean, it's related because you can see how these loops or sheets tend to come out from where sunspots are. You can see the plus and minus there. The sunspots have opposite polarity. And so it connects the two sunspots. Well, occasionally you can get a magnetic reconnection event as these things wiggle around and touch each other, and it can blow off some of that plasma that then flies toward the Earth. And that's where you get these solar storms.
So if you ever see a sunspot, that's probably there's going to be a loop above it, coming out of it.
Right. And it may be huge like the one shown here, or it may be quite small and just local to the sunspot.
But the sunspots are on what, an 11 or a 22-year cycle?
It's a 22-year cycle, but to us it appears as an 11-year cycle because there are like two phases to it.
Therefore, these loops are on that same cycle, I would think.
The population of the loops is kind of on that same cycle as the population of sunspots.
So if you get a really bad one, a big one that's going to fly all the way out to Earth and screw up our satellite systems and electronics, that's just a major one, right?
Yes.
The ultimate.
Right, and we talked in one of the previous issues about the Carrington event, which was a huge coronal mass ejection that hit the Earth.
What year? 1800s?
1850, 1849, something like that.
So it hit the telegraph, screwed up the telegraph.
Because of the wires.
Guys that were operating the telegraph machine got shocked.
Right, and started fires in some of the telegraph offices.
And they haven't had one like that since?
There have been a couple like that since, but they have not hit the Earth.
Oh.
And some of the smaller ones have caused power outages, like the power outage that started in Canada years ago and blotted out the East Coast.
Right. Wonder what
And
the
here's a
odds
great picture Tom has.
are. Uh-huh. Keep that on there. That's one.
Yeah.
So what do they call that? Before the Carrington event was a what? A superstorm? It's not a loop.
It was a coronal mass ejection.
Okay, so it didn't loop back. In other words, it just
The
went
loop,
on.
gets this
Sorry,
That was totally
Bruce.
unintelligible.
I know some robots who would know exactly what you just said, Bruce. Sorry about that, my friend.
Now we've got a lot of great pictures of these now because we have a lot more satellites focused on the sun, because we've realized what a danger some of these events can be for us with a technological society where we're relying on electricity and electronic devices that can be damaged by these events. There's a series of, I think it was 7 or 9 large transformers in the US that are used to distribute power throughout the country. And they're very vulnerable to events like this. And they're also very expensive to build. So there are no spares laying around. And if these things get cooked by a coronal mass ejection, it may take years to restore power to parts of the US. So because we don't have spares laying around, because they're expensive, and American industry only looks at the short-term bottom line. So it's a big worry.
Well, the title of this segment is Coronal Loops May Be an Illusion. So the illusion is what?
The fact that they're loops may be an illusion. They may be these sheets of current. And Jerry actually included a picture of the Veil Nebula, which is also a similar type illusion, where you have an expanding bubble that's not really smooth and uniform like a sphere, that's expanding outward from a supernova explosion. And in the areas where there are density variations in it, or where you're looking through the edge of the loop, you can see these same kind of features in this Veil Nebula as you see on the edge of the sun. So here's a picture here. It's a great picture of filaments in the Veil Nebula.
Ah, filaments in the Veil Nebula. That's not gas, or?
Yes, it is. It's gas.
Oh, it is. Okay.
Yeah.
But they're in a filament style.
Yeah, well, they're fluorescing, and in areas where you're looking at denser pieces of it, it looks brighter. It's a similar effect to like the Ring Nebula. Okay,
Right.
so the Ring Nebula is a planetary nebula, and well, okay, I picked a bad example, but some of these planetary nebulae are spherical, but when you look at them, they look like a donut around the star, because when you look around the edges of that sphere, you're looking through more dense material than when you look directly at the central star.
Huh.
Okay, and so it looks denser there, and it looks like a donut. Actually, with the Ring Nebula, we think it's actually shaped like an hourglass, and we're looking at it end on, and so that's why you see a circle.
Is that the
But
Ring
it's a similar
Nebula?
thing, because you're looking through denser areas.
But are they planets?
No, this is just fluorescent gas, Ron.
No, but on the Ring Nebula, you said planetary. I think you said the word.
It's a planetary nebula. That's the end stage in life of a low mass star like the sun.
And planetary
They're
nebula.
called planetary nebulae because they're often rich in fluorescing oxygen, which appears green. And so in the late 1800s, when they got spectroscopy and they looked at these things and they saw the green, and they had discovered the planets Uranus and Neptune, which look greenish, they said, oh, these are planetary nebulae. They're clouds that look like planets. They
Oh,
have nothing to do with planets. They just happen to have that same color. And when they actually took the spectroscopy of them, they could see that it was like a gas fluorescing, so like oxygen and nitrogen.
okay. Since I represent the non-professional layman, I stand educated now. I thank you. But I have one final question about the loops and the ejections from the sun. They're based on the magnetic, which
Yes.
planets can have. We have a magnetic field. A lot of our planets don't. Sun has one, but it's all based on metal inside, right? The metal.
Not metal. It's moving currents, moving electrons that do it.
So it doesn't need just iron. The minute a star hits iron, making iron, it's gone, right? That's the beginning of an explosion. So I'm trying to think what other metals are below iron that it goes through. Aluminum?
Ron, it has nothing to do with metal. It's just moving electric currents. These are the sun is a plasma, so the electrons are dissociated from the nuclei, and they're moving around. And when you have a moving electrical field, you generate a magnetic field.
So they think all stars have them.
Some stars more than others. It depends on whether you have these convection currents going along, where you have the moving electrical fields.
And there are some incredible nightmare stars called magnetars, which are nothing but a
Those are a little different in that they're neutron stars, so they're more like a solid body, but they're rotating rapidly, and they have like a conductive fluid of electrons that may be on the surface.
Gentlemen, we're down to the wire, and I thank you, Bruce, for trying to stay with us, and I know you'll get that fixed, and we'll see you again next week. But I had one question I was going to throw at you for the future. Maybe we'll run this by the president. I think he knows. I think Chuck would know this, and I'm going to ask Tom if you know. If you do, we'll kick it around sometime in the future. The difference between centrifugal force and something I just learned is called centripetal force. You know what I'm talking about, Chuck?
Yes, one of them is kind of what's called a fictitious force, but yeah.
Okay, well, I saw it demonstrated, and I don't understand the centripetal or centrifugal, depending. I know what centrifugal force is.
Yeah.
Something moving tends to stay in its regular position, but I wanted to bring that up, and thank you, Tom, for your work and your dedication. You are just indispensable, my friend.
Yeah, this is a lot of effort, so thank you.
And
No worries.
tomorrow night there'll be another shop, right?
Telescope workshop, yeah, 7:30 p.m.
Okay. Anybody signed up to appear on that? Or anybody can tune in and watch?
Whoever got our message that it's on, they know the Zoom link to it. So you have to contact me to make sure you're not a fictitious person.
Okay, well, Bruce, we'll be talking to you in the future once you get your sound working, and don't stay away from the BA2, that Omicron variant, or the next one too, or the one after that. And we'll do it all again a week from today on the 20. My God, we're going through April like crazy. That was the 59th edition SBAU Astro Hour. Thank you on behalf of the club, and we'll see you guys later. Appreciate it.
All right, Ron, thanks.
Thanks, everybody.